Today's video will explain the difference between iteration and recursion. Hello, I'm James Helfrich. I often hear it said, oh, this is an iterative problem or this is a recursive problem, as if it's mutually exclusive. Well, this video will explain that all iterative problems can be solved recursively and all recursive problems can be solved iteratively. To demonstrate this, let's take a look at a traditional iterative problem. Here I have a collection of transactions, and I want to find the balance, which means I'm going to iterate through all instances of the transactions array and sum up the balance. Well, how can we solve this recursively? First of all, I'm going to have the same function, compute balance, and then notice how we're going to set balance equals 0. So that's going to be my return balance equals 0 stop condition. In other words, if there's 0 elements in my transactions array, then I'm going to return 0.00 as my balance. And so that's my end condition. Next, in an iterative solution, we say as long as I is less than num. We're going to keep looping as long as I is less than num. Well, we're going to do the same thing with my recursive solution. We're going to say as soon as num equals 0, then we're going to stop. Now, the progress step in the iterative solution is I++ and balance plus equals transactions. So we're going to have the same thing in the progress step in the recursive solution. We're going to take one instance of a transaction, num minus 1, and we're going to add it onto, just like the plus equals in the iterative solution, the rest of the list. In this case, transactions of num minus 1. Okay, so now we have our two solutions, my iterative solution and my recursive solution. Let's see how they compare. Now, I'm going to perform a program trace on the iterative solution. I'm going to say at line A, let's say I have 3 transactions and the value is 100, 200, 300. Notice how I in balance is not initialized yet. At line B, then I'm going to say, well, balance equals 0. On line C, I equals 0, balances remain unchanged. And D, I'm going to take the value of transaction 0 and now I'm going to add it onto my balance. Go back to line C, now I equals 1, and I'm going to take 200 to add on my balance as 300. Go back to line C, now I equals 2. Now I'm going to take the transactions of 2, which is 300, and add it on to my old balance, which is now 600. Now I'm going to go back to C. Well, I'm going to finish my loop there because I is no longer less than num, and I'll return 600. Now let's do the same thing with recursion. I'm going to number my lines of code so I can perform a program trace. And notice this time I have a much smaller number of variables. I don't have an I and I don't have a balance, but I'm going to add a return column here. So I'm going to start with num equals 3. Then I'm going to say transactions of num minus 1, which is, since num is 3, that's transactions of 2, that's a 300. And I'm going to add 300 onto whatever the result of compute balance is, which we don't know at this point in time, so we're going to have to come back to that. But now in order to call compute balance of 2, now notice how my num equals 2. And now transactions of 2 minus 1 is 1. So I will add transactions of 1 onto my balance. So it's 200 plus something else. Now I'm going to go back to line 1. Now there's only one element in my collection. And now transactions of 1 minus 1 is 0. So transactions of 0 is 100. And so the result is 100 plus something. Now I'm going to go back and call compute balances where num equals 0. Now on line B, I'm going to say if num equals 0, it does. So I don't go to line D, I go to line C, and I'm going to return 0. Now I'm going to return 0 out of here. I'm going to go back to the instance of compute balance where num equals 1. And now the value is 100 plus something. Well, that something is now known. Now it's 0. So 100 plus 0 is 100. Now that is finished. So I will now go back to when num equals 2. And that's 200 plus something. Well, that something is now known. It is 100. So 200 plus 100 is 300. So now I'll complete that iteration. And now I'm going to say compute balance where num equals 3. In this case, is 300 plus something. And that something is now known, 300. And so that returns 600. Now, observe how we have the same parts of the iterative solution and recursive solution, but the program trace looks completely different because the mechanism by which we loop through the list of transactions is completely different. Let's take a look at another example. Here I want to compute factorial, and I'm going to use VBA for this one. In my recursive solution, I'm going to say if num equals 0, return 1, because 0 factorial is 1. Otherwise, I'm going to return n plus factorial n minus 1. Okay, so we are counting from 1 to n, and so I'm going to say factorial. Once again, the function signature is the same. And now notice the return one case here. I'm going to say, hey, integer equals 1, my value equals 1, and 1 is my return type. If n equals 0, then I'll say for I equals 1 to n, and then multiply n by n value times equals number. So the recursive solution, the iterative solution, side by side, let's see how they work. First, we'll do the recursive one. I'm going to number my lines of code A, B, C, D. On line A, I'm going to say factorial of 3, so n is 3. On line B, well, 3 is not 0, so I continue on to D, and that's 3 times factorial of 2. Well, let's call factorial of 2, and 2 is the value of n. N is not going to be 0, so I go back to line D, and it's 2 times factorial of 1. So I go back to 1, so n equals 1. 1 does not equal 0, so I go to D, and it's 1 times factorial of 0. Now I go back to A. Now n equals 0. Does n equal 0? It does, so I return 1. Now that I've resolved this, I go back to my original call 1 times 1, which is going to be 1. And I go back to my original call 2 times 1, which is going to be 2. Go back to my original call 3 times 2, which is going to be 6. And that's my recursive solution. Now let's compare that with my iterative solution. Once again, I'm going to number my lines of code. At line A, n equals 3, the same test case I had with recursion. Number and value are, at this point in time, not defined. On line B, value equals 1. On line C, then number is going to start as 1. Now, since 1 is less than n, less than 3, I'm going to go to line D. And now I'm going to say value, which was 1, equals value times number, which is 1, which is going to be 1. Now go back to line C, numbers can increment to 2, and then 2 is less than or equal to 3. I'm going to go up to line D, and now 2 times 1 is going to be 2. Go back to line C, and now number equals 3. Is 3 less than or equal to number? It is. Go to line D, value, the old value, which was 2, times the number, which is 3, is now 6. And now that I finished my loop, I'll go to line E, and I'll return 6. Once again, we have the same operations going on, the times equals, and we have the same number of iterations going on. It's just the mechanism is completely different. In the iterative solution, I have to use the number iterator. In the recursive solution, I call factorial number times, but the end result is the same. This is example 16.1 and 16.2 in the recursion chapter of the software design textbook.